Good morning, students. My name is Faisal Sheikh, and today we're going to start chapter 2, Acid, Base and Salt. First of all, I want to tell you that acid, base and salt is not only in chemistry textbook or in chemistry lab. These are we are using in our day-to-day life. For example, vinegar, tomatoes. They are having sour taste, and we are familiar with that. Sour taste means acid. Acid are having sour taste. Vinegar is having acetic acid. Tomato is having oxalic acid. Soap which we are using in day-to-day life, toothpaste which we are using, they are basic in nature. Table salt which we are using in cooking, or chalk which we are using in schools, these are salts. Now let's talk about definition of acid. According to Arrhenius, Arrhenius is the name of scientist. He has given a definition of acid like those substances which give hydrogen ion when dissolved in water. So those substances which when dissolved in water and give hydrogen ion. And to be precise, I will say hydronium ion. Why? Because hydrogen ion are unstable, and when they react with water they form hydronium ion. So for example, hydrochloric acid, nitric acid, sulfuric acid, these are the example of acid. These are mineral acid. Now let's take example of acid, hydrochloric acid. When react with water or when dissolved in water, it give hydronium ion and chloride ion. So we can relate the definition here. The substance which when dissolved in water and give hydronium ion are known as acid. So this was about acid. Now let's see about base. Now let's see about base. According to Arrhenius, base are those substances which give hydroxide ion when dissolved in water. OH minus is hydroxide ion. Metal oxide and metal hydroxide are base. Metal oxide that are like for example MO metal oxide and metal hydroxide MOH, that is for example NaOH, KOH, or metal oxide, calcium oxide, zinc oxide. Zinc oxide is actually having dual nature, which we're going to talk about later. But like for example sodium oxide, aluminum oxide, these are called basic oxides. Now let's see definitions is related or not. Na2O in solid state react with water, it give NaOH in aqueous solution, but it get ionized, so you will get hydroxide ion in aqueous solution. So this substance is a metal oxide, which is a sodium oxide. Sodium oxide when dissolved in water, it gives hydroxide ion. So metal oxides are basic in nature. Metal hydroxide, like this sodium hydroxide, in solid state, when dissolved in water, it dissociate and it gives Na plus OH minus in aqueous solution and water. So you will see NaOH plus H2O on reactant side, and on product side is also NaOH plus H2O. But it is in solid state in the reactant side, and in product side it get dissolved and you get Na plus and OH minus and excess amount of heat energy. This is a exothermic reaction. So in other words, we can write NaOH plus water, we get Na plus hydroxide ion. So base gives hydroxide ion and they are called base according to Arrhenius. And let's now talk about identification of acid, base and salt. So by taste we can identify acid, base and salt, but we can't taste each and every chemical. So we have different method to identify. First method is about taste, that is acid is having sour taste, base is having bitter taste, salt is usually salty. Some salts are bitter in taste also, some are sweet also, but usually salt are salty. Now we're going to talk about identification of acid, base and salt. Let's see how many ways we have to identify whether this compound is acid or base, or sometimes they are neutral too. Let's see the different kind of identification method. Good morning, students. So we're going to talk about identification of acid base in compounds. So we have certain indicators which indicate about whether a compound is acidic or basic or neutral. So we can say acid base indicators are categorized in color change type of indicator and order change type of indicator. In color change type of indicator, in different media, it means like in acidic medium they have different color, in basic medium they have different color. So the color change type of indicator are further classified or categorized in two types: natural indicator and synthetic indicator. In natural indicator we have so many things, but we're going to discuss few like turmeric, red cabbage, litmus, and the other flower petals also. But let's talk about turmeric. Turmeric is yellow in color, but in acidic medium the color remains same, that is yellow. But in case of basic medium, the color of the turmeric changes to reddish brown. Now let's talk about red cabbage. Red cabbage leaves are first boiled and extract is prepared, which contain anthocyanin, and this on addition with acid it turns red in color, and in basic medium it turns bluish green, and in neutral solution it is purplish, or we can say purple in color. So you can see as they are changing their color, so we can use them to indicate whether a compound or whether a substance is acidic or basic. So now let's talk about litmus. Litmus is actually a dye, we can say, which is prepared from a natural substance like lichens, which are from Thallophyta. But let's talk about litmus paper. Litmus paper are red in color and blue in color. Two types of litmus paper we have. So red litmus paper, when react with base, it turns blue litmus. Base turns red litmus paper to blue litmus. And blue litmus, if you add base to it, it remains same. So base only change red litmus to blue litmus. It does not have any effect on blue. Blue remains blue in color. Now let's talk about blue litmus. If blue litmus is we can say mixed with acid, it will turn to red litmus. And if red litmus is used along with acid, the color remains same. So this was about the identification of acid or base with the help of litmus paper. But students, I want to tell you that this will work only if the acid is moist or base is moist, or you can take litmus paper and moist it. Why so? Because for example, acid must have H plus ion. If you are taking dry litmus paper and dry acid, you won't see any considerable change in color. So you have to take moist litmus paper, or either the acid should be in moist condition or in aqueous solution. So it will release H plus ion and you will see change in color. So therefore you may get questions like, why dry acid have no effect on litmus paper? Because in dry condition the acid does not have, you can say, H plus ion. For example, hydrogen chloride gas, HCl gas. HCl gas in gaseous condition does not have H plus ion, but if you add some water, it will change to aqueous solution, that is hydrochloric acid. Now it will have H plus ion, and this H plus ion are responsible for the acidic nature, and they will convert this blue litmus to red. So students, please make sure that you remember red litmus change to blue in case of basic medium, and blue litmus does not have any effect in basic medium, it remains blue. While the blue litmus change to red in acidic medium, and red remains red only, no effect. And neutral solution does not have any change. Neutral solution will have, like for example, if you take litmus paper, red or blue, and dip in neutral solution, it will remain as it is. So we have talked about nature indicator, which were obtained from nature: turmeric, red cabbage, litmus. Now let's talk about synthetic indicator. In synthetic indicator, there are several indicators. We will talk about phenolphthalein and methyl orange. Phenolphthalein is originally colorless, and methyl orange is orange in color. If phenolphthalein is mixed with acid, the color remains same, that is colorless. But if phenolphthalein is mixed with base, so in basic medium, the phenolphthalein turns pink or dark pink. Methyl orange, on other hand, is orange in color, but in acidic medium, it changes to pink color or red in color. While in basic medium, methyl orange changes to yellow. So this was about synthetic indicator. They are prepared in laboratory. Now let's talk about order change type of indicator, which are also known as olfactory indicators. Olfactory indicators are those which change their order in different media, especially in acidic or basic medium. So we can say substance which change their order, smell, in different media like acidic or basic are known as olfactory indicators. We have certain examples over here: onion, vanilla, clove oil. All these three have no change in order in acidic medium. Their smell remains same in acidic medium, but they change their order in basic medium. So this was about the acid base indicator.